Okay, now we're going to continue the previous analysis, but now instead of hierarchical clustering, we're going to perform k-means clustering. The function k-mean clustering takes um, a matrix. It computes the distance on its own. So we can actually feed it the expression matrix. We do have to send a transpose because it will compute distances between rows. All right, so the way we use the function is also in base. It's called k-means. And it takes as input the original matrix. And again, it's going to compute distance between rows, so we have to transpose it. And now, as we discussed, we have to tell it how many clusters we want it to find. So let's say that we have, let's remind ourselves how many tissues we have. Seven, so we're going to say 7 centers. Okay, so centers is equal to 7. And we don't know, we're going to let k-means choose the location of the starting values. Okay, so now that runs k-means. It's computing distance, so it takes a little bit of time, but now it's done. And now we can, for example, make, again, a table where we see the tissues, the actual tissues, and the clusters that we got. So let's call that clusters, and it's in the KM object has this component called cluster that gives it the different numbers. Let's actually look at that, so you can see it gives us a cluster number for each sample. Yeah, so you can see there how that worked. All right, so here it is, and we can see it did a pretty good job. You have cluster number 2 is all it's all colon and placenta, but endometrium got its own, no mistakes there. Hippocampus as well, kidney. So it worked pretty well at clustering the tissues by group. Yeah. So another thing I want to show you is you can visualize this. If we're going to visualize this, we're going to plot. So we can use MDS, the multidimensional scalings, to be able to plot in 2 dimensions. So we're going to do that real quick. Now we're gonna, that works on D, which we already calculated in the previous video. If you want to remind yourself how we did that, we just did this. Right, so that's how that would work. We compute that, we can plot them, and we can see that we can add color to see the different colors that were clustered here. So that's KM cluster. And there you go. So you can see how these different points got clustered. Again, but these are just 2 dimensions, and there's more dimensions than that. So you can see that these are all on top of each other. So it's hard to see how it would cluster them, but that's because there's other dimensions it's using for this distance calculation. So that's how you use the k-means cluster. Now, one thing I want to show you is that if you run it again, you get a different answer. That's because it chooses the starting values differently. You see that one didn't work as well as the first one. You get like cluster 1 is those are the brains actually, but you have liver is split now, kidney split. So every time you run it, you can keep running it over and over again, and you're going to see you're going to get different answers every time. So that's something important to keep in mind about this function, that because the starting values are random, it gives you a different answer every time. You can choose the starting values to avoid that, but then that requires a bit more work on how to decide what starting values to use. But this is the general idea of how to use k-means in R